Hey there, students. I wanted to get back to Codesters and talk about what does it mean to have a physics engine? Does it have to correspond to real physics? Does it have to match our experience of reality? We might need to do some experiments to see how closely a given physics engine actually matches real-world physics. But on the other hand, we could take another point of view and just say, whatever physics they give us, what can we do with it? In other words, we don't need to know right offhand if it matches reality or not. It's just there's a set of rules, and as a result of those rules, certain things happen. Now I've already got some bugs here I need to fix. What this is going to do is launch a UFO in the very lower left-hand corner. It's going to give it a pen color and set the pen down, set the size, and launch this thing at a certain speed, a Y speed and an X speed. Since I've got the same speed for both, it should gain altitude at approximately a 45-degree angle. So we expect it will head up this way. Now, the first thing I do is, okay, there's a need to stop the action here for a sec. Let me debug. So I haven't touched the source code. It's just working now. So let's see if we get that bug again. So I'm launching this thing at 45 degrees. It says escape velocity achieved, if you can't see that. And what's happening is every 0.2 of a second, every 1/5 of a second, I run a program called interval, which checks the current height of the UFO. And if it's greater than 100 feet, we'll just say feet, could be meters, whatever unit you care to use. And it hasn't escaped yet. In other words, we're still not at escape velocity or escape. I just create this space where if you get a certain height over 100, we're going to call that escaped. We're going to set escaped global to true, and then we're going to turn off gravity for your sprite. So if it gets to that height, it's basically free, and it gets to leave out the top. I basically slow it down. The X and the Y speed, I slow it down, but there's still bouncy walls on the sides and on the bottom, and I only give 10 seconds for whatever's going to happen. So stage.wait says whatever this experiment is, it's going to only last 10 seconds and then you're cut off. So that's like running time at CERN or something. You don't have infinite time to goof around. So what we're going to do here is set the gravity to a certain constant and then shoot our little guy at a certain speed. Now you've already seen what happens at 2020. What if we just shoot him at 1010? Leave gravity alone, fire, much lower down. He doesn't get very far at all, right? He just starts bouncing around, hitting the floor. I've got the pen down so we see a nice tracery, but he did not escape velocity. So what if we turn gravity way down, say to 1? We'll still shoot at 1010. Are you going to get out of the gravitational field, Mr. Spaceship? Now we got that problem that it doesn't know how to. Okay, so on line 22, we're talking about the sprite before it exists. And I think this has to do with the interval program firing before we ever define a sprite. So what I want to make sure of is that we always have action before we even bring this stage interval guy into play. So action is the opening set of actions where we create the sprite and fire him in a direction. We've got to do that first before we start doing any interval measurements where we're getting the height. So I've refactored the program and fire again. There it goes. It's doing well. I think it's going to achieve escape velocity. Yes, it has. So with gravity at only 1, it gets away. How about gravity set to 2? Fire. Slower. Still, I think it's going to get out. Very good. Okay. Again, we only have 10 seconds for all of our action to take place. All right, I'm going to keep increasing the gravity, and I'm assuming, unless something is amiss, that at some point it's not going to make it. It's not going to get out of our gravitational field. This one's doing it. Oh, wait, no, no, and now he's coming down again. Okay, so gravity set to 3 is too much for 1010 to get us out. But what if we set it to 1515, or I could just go straight up or something? We could try different things. Here he goes. He made it out. Now it slows down again when he escapes, and that doesn't necessarily correspond to anything in a real escape from Earth's orbit, or even escape into Earth's orbit. Those discussions could come separately. All we're saying is, hey, we have a physics engine. We can start running experiments, and we can limit how long we mean by an experiment. They don't have to be open-ended time-wise. So that way we can get, once we've defined the length of an experiment, we can expect to get so many results in such and such a time, if that's important to us, right? So I would play around with this code. I'm going to post a link to it in the YouTube, and have fun with Codesters. There's a lot more to play with. Talk to you soon.